So what's your observation about the horizontal asymptote we found when we evaluated this limit to infinity and the original function we started with? Do you think you could have found the horizontal asymptote, the limit, aka the limit to infinity, without doing all of this? Do you see it there in the original question? Yeah, you do, don't you? When the power in the numerator is the same as the highest power in the denominator, your limit to infinity is just going to be the ratio of your coefficients. So think again about what that would mean. As our x's get infinitely large, subtracting 2 is insignificant. In fact, compared to squaring x, subtracting x is insignificant. So the end behavior model for the top is 3x squared. The end behavior model for the same reasons on the bottom is 5x squared. So there's your end behavior model. X squareds cancel. Your limit to infinity, 3 over 5. Power on the top equal to the power on the bottom. Okay, let's look at something super complicated, because we're going to have to look at what happens with square roots and negative numbers. All right, fun times. So find the horizontal and vertical asymptotes for this function. Okay, let's start with the easy question. The vertical asymptotes. What color was I using? Pink. Okay, so vertical asymptotes means we are looking to the limit at a point. Before you start, would you please tell me non-permissible value for that function? What can't x equal? Well, you can't have a 0 in the denominator. It can't be 5 over 3. Okay, if x is 5 over 3, you get 0 in the denominator and you get a number up. Okay, so we know we've got a vertical asymptote at x equals 5 over 3. I want to know what happens as you get closer and closer to your non-permissible value. So that is, I want to know the limit. What's the limit as x approaches 5 over 3 from the left for this function? Okay, so require focus here. If you look in the numerator, would you agree with me that no matter what x value I put into the numerator, I'm going to square that x value, multiply it by 2, add 1, and then take the square root. No matter what I put in the top, it's going to be. So if I get a positive on the bottom, this would be going to positive infinity. If I get a negative on the bottom, positive, negative, it would be going to negative infinity. Are we following? Yeah, okay. So then we say, if we're saying x approaches 5 over 3 from the left, we mean we are choosing an x value smaller over 3. Okay, like 4 over 3 is smaller. If I put 4 over 3 into the denominator, can you please tell me if my answer would be positive or negative? 4 over 3. 3 would give me 4 minus 5. You all see you get a negative. Okay, so as x approaches this non-permissible value, asymptote. If I'm approaching from the left, negative infinity. And because on your vertical asymptote, you can approach that non-permissible value of 5/3 from 2. What happens if I approach it from the right? Is I know that if I do direct substitution, I get a number over 0. So this vertical asymptote at 5 over 3, i.e., value is going to. Question is, am I going to put a plus or a minus in front? So if I choose a number for x that is 5 over 3, like 6 over 3, the denominator will be positive, and positive infinity. So what I do in this function, here I'm going to start a very rough sketch of this. I know that I've got a vertical asymptote right here that equals 5 over 3. And I know that for the right, it goes up to positive infinity. On the left, it's going to go down to negative infinity. It's a vertical asymptote. I don't know what happened after this, but I know this and this. Okay, so then those are horizontal. That is the limit as x approaches its possible value. Makes the denominator 0. Your vertical asymptote limits as x approaches positive or negative. Okay, so let's see if we can find if there are any horizontal asymptotes for this function. Okay, and this one is that. Let's start with the x approaching positive infinity because I know it is and the negative. Okay, so the limit as x approaches positive infinity, this function, square root 2x squared plus 1 over minus 5. So my strategy for infinity is that I multiply by 1 over the higher of x in the denominator. And what I do to the bottom, I have to do, well, the higher power of x in the denominator is power of 1. So I'm going to multiply this top and bottom by 1. So I'm going to give you